So in the previous video, we talked about what we call the sum and difference formulas for cosine. In this video, we're going to talk about what we call the sum and difference formulas for sine. And those are when you have the sine or want to take the sine of a sum of two angles or a difference of two angles. Here are your formulas. The sine of alpha plus beta is the sine of alpha times the cosine of beta, the other angle, plus the sine of beta times the cosine of alpha. Your book has this written as sine of alpha times the cosine of beta plus the cosine of alpha times the sine of beta. Multiplication is commutative, so this is the same thing. Now, the sum and difference formulas for sine are related in the same way that the sum and difference for cosine are related. Those formulas are related. With cosine, where I had a plus here, I had a minus here. And when I had a minus here, I had a plus here. With sine, I have a plus in the left-hand side. I have a positive. I'm looking for the sum, and I have a sum here. So the sign does not change. But the order of the terms and the factors does change. So, but the sign of the difference is the same as the sign of the sum, except for the sign, S-I-G-N, right? So here I'm going to have the sine of alpha minus beta is equal to the sine of alpha times the cosine of beta minus the sine of beta times the cosine of alpha, or if you prefer, the cosine of, wrong pen, the cosine of alpha times the sine of beta. These are, as was the case in the previous video, two formulas that you're going to want to include on your note card. You kind of never know when it might be handy to use one of them, or when you might be asked to do a problem. For example, find an exact value for the sine of this sum of two angles. We can rewrite the sine of 3 pi over 4 plus 2 pi over 3 as the sine of 3 pi over 4 times the cosine of 2 pi over 3 plus the sine of 2 pi over 3 times the cosine of 3 pi over 4. Now, I'm not going to work this one out because I've done a lot of those, but I will remind you that this is not the sine. 3 pi over 4 is in quadrant 2, so it's going to use a reference angle of pi over 4, but because it's in quadrant 2, it'll still be positive. Cosine of 2 pi over 3. 2 pi over 3. 2 pi over 3 is also in quadrant 2, so this value will be positive. Cosine of 2 pi over 3. 2 pi over 3 is in quadrant 2, but cosine is not positive there. So when you work out what this value is, the cosine of the reference angle pi over 3, it's actually going to be negative. And 3 pi over 4 is also in quadrant 2. Cosine is not positive there, so this value will have the same numerical value as the cosine of pi over 4, but it will be negative because cosine is not positive in quadrant 2. So once you know those values, you can just plug them in. They'll have square roots and fractions and all kinds of stuff in them, and you can do the arithmetic and come up with an answer. Final answer here would be either -1 minus the root 3 all over 2 root 2, or -1 plus root 3 all over 2 root 2. Just algebraically speaking, remember that this basically means you're distributing this negative across your numerator. So that's why that one's negative and this one's positive. So that's the answer you should have got by doing this problem on your own.